So it's 8:20 in the morning on Walkie Talkie Wednesday. And it's 8:20 in the morning because I've got to leave here at just before 9:45 and go and do something in Grantham, and then I've got an appointment at Worksop in the afternoon, so we didn't want to miss out Walkie Talkie Wednesday, so I thought I'd jolly well get on with it. And any of you who make videos will know that even if you're doing a 45-minute, 50-minute job, it might easily take 3 hours if you're recording it. So we'll get on with it, and this is the Binatone Long Ranger 40, which is a very high range radio in an easy terrain walkie-talkie test we did in the 80s. We got 14 miles on one of these. Now at the moment we're only doing tough terrain tests, so we're not getting fantastic range, but that will change in the future when we kit out our mobile van control room thing so we can do long range tests. So here we go. This is a Scruffy, and it says it's come, and it's still in its carrying case. Now the killer on anything like this, be it any make, is broken antennas. There is nothing that I'm aware that you can do if the antenna is broken. And when I bought this, I was assured that it wasn't. I can tickle the camera with that. Whoops. So that is the key, because if you've got an element missing, obviously the SWR is going to be out and the radio won't last long with a high SWR. So it reassures us on the back. There's a chart there which tells us that channel 1 is 2760125 and channel 40 is 2799125, which is true. Now this should have a battery pack in it, and it should take 8 AA throwaways, or with 2 dummy batteries, 10 rechargeables. So we'll just open that up. You can put a coin in this thing, and of course the battery pack's missing. Now we haven't got 10 battery packs here at the moment, we've got 8, so when we do the test on this I'll make sure it has got 8 AA's which are non-rechargeable, and that way the test will be fair. And this is time and time again I've said that you see these on eBay and they've just shoved a PP3 9-volt battery on there, and they show it on lit up with a dim display, and they must, I just don't get how people can think that a radio can do 4 watts out of a PP3 battery. Anyway, that's told them. Now then, let's open it up. This is obviously going to want some cleaning as well. It's in a bit of a state. Now these are synthesized. They do a 6-channel one and a 12-channel one, which use the same well obsolete synthesizers. There's the wrong screw here, even when these were made in 1981. So if you get the Long Ranger 6 and the Long Ranger 12, I actually wanted to do one of those. I could see it on one of the shelves and I can't get to it. There's too much clobber, so it's something which we will explore in the future. It's our similar range, and the 6-channel one, I don't think it's crystal controlled. It isn't. It's synthesized. It's a strange choice of channels, however, like 6, 7, 8, 9, 10 and 11, something like that. So this is not fun to take apart, and it's even less fun trying to thread the PTT switch back together when you come to reassembly. So these are a great set, they work well. It's got high-low power. You can switch the channel display on and off and save power. On-off volume squelch, channel change, and quite a good range of sockets. You can have extension speaker, an extension antenna, charger or battery mains adapter. But the killer is there's no external mic. So this isn't something you can these days fling on the seat of your car if you've not got a CB equipped, shove an aerial on the roof and use like you can with the realistic 1005, 1001, where you've got that extension mic facility. So all we've got on this is a hand-drawn circuit diagram, and I don't even know where that came from, and it's been photocopied about 20 times, and it reassuringly tells us it's 1981, which we know anyway. So we've got a bit of something there, and this is for the 6 and 12 channel one, but it'll be the same. don't know if we can see the synthesizer chip down there. Yeah. But whether I can get the light on it and enough magnifying glasses to read what it says. So it's a MSM 58078. No, it isn't. It's an MSM 5807 RS. Nothing to do with radio spares. It's MSM 5807. So there I say they were well obsolete when these were made. Now we're not going to have to mess with the VCO on this, I'm quite sure. So what I'll do, I'll connect it up to power, and we're going to do a little chart, because I'm sure it's going to be the same for the 6 and 12 channel ones when I am able to get to them. So I'll draw this out and I will come back to you when we connect it up. So I've got to the stage now where hopefully we've got where the adjustments are. It looks like the transmitter starts here and works down. That's 12, that's 18. Notice the output transistor is a 2SC2166, so you know it's really on top of the job, that, and would survive quite a mismatch. And then the receive side looks to be like it's going down this way, so it looks like it starts at L6 and 5 and 4 and 3 and 2 and so on. What I didn't notice before is that the receiver has a crystal filter in it, and that's quite surprising. There's only one adjustment, it's RV3, and that I know to be deviation. So let's switch it on, put that to one side. So make sure the power supply is at 12 volts. Okay, so I can't see anything on the channel display. That's a really handy start. So hopefully we're on channel 20 by using the pointer there. That could just be dirty. I don't think there can be that much wrong with that, so we'll come back to that. So what I've done is to connect the test instruments to the extension aerial socket, and it reassuringly tells us it's sent a positive for the power connector and that it needs at least 450 milliamps, and that's good. So I will just press transmit, and it is doing something. And there's the door. Okay, that dealt with the door. That was a builder doing some unexpected building work. So we should get some good sound effects, no doubt, as this progresses. Right, that gives me half an hour to be with you on this. So I'm going to go into transmit, and it's awkward because you've got to fiddle by pressing the... Oh yeah, that's interesting. Is there a loose wire? Well, this one's certainly not doing 3 watts. See what it's doing on low power. Very low. I'll just switch the other camera on so you can see what's going on here. Well, I'm not happy about whatever that crackle is when I fiddle with the wires. So on low power it's doing stupidly low power, and on high power it's doing 1 watt. That's a bit strange. But it's drawing 700 milliamps. Hope our aero connector isn't dirty. The potentiometers there are sealed types, but they are riveted on contacts, and usually the rivets go right through to the insides. So fingers crossed. Now I did have on here a fiberglass brush, so I'll just make sure that our connector is clean. It's difficult to clean a phono plug socket on there. No, it's weird, only doing 1 watt. Okay, we've got a short Ranger 40 by the sounds of this one. So I'll start with the first of the coils of a transmit, which is going to be that one there, which looks broken and is broken. So we'll move on to the next one. And that was definitely at peak. Ah. And that most certainly wasn't at peak. Go through these again. Now I know they're loose enough, I'll use the ceramic tool. Got peak on that. It looks like somebody's tweaked it down and not tweaked it up at some time in its life, doesn't it? There are some wallies. I mean, we're now at 3 watts. Okay, I'll just see if we can move this one. Now we're in trouble there because I'm going to have to try and move this, and I'm going to try and do it by putting the cutters into what's left of it. Otherwise I'll have to unsolder it, and it's going to be an absolute job and a half. I'll pause the video. Well, I have actually managed to get it out. I've ruined my fingernails, but I've managed to get it out, and it's of course broken at that end. I was hoping it's double-sided so I can just pop it back in the other way around. I've not damaged the core in any, the coil in any way. what I managed to do, it was nearly at the top, it was nearly flush with the coil, and I managed to get the side cutters in without damaging it, just enough to move it half a turn. Once it was moved half a turn, I could just get my fingernails on the edge, and I've just eased it round until I managed to get it out. So now we'll put it in the other way round. So we'll go back into transmit if we've got the power back on it. Oh, we're shorting out the terminals again. Perhaps it doesn't develop any power till we get it in there somewhere. I don't want to cross thread it. Okay, so now we're on the other scale. So let's look where we are. So it's 3 watts. Just make sure everything's now peaked. Now this one's hanging out of its out of the core. I'm just going to go down and see whether it's on a false lock point, because that can happen. No, it's not on a false lock point. And then back to the one we've been fiddling with. Just go around them again. I'm hoping to have time to do field strength with you, because field strength will be adjusted, I think, with this one down here, which is L1, and that is matching the antenna to the radio. Now it's been wax sealed, so it probably doesn't need adjusting, but it might be a useful thing to show using a field strength meter, but we'll come to that right at the end if we've time. Wow, I just got an RF burn from the antenna. That was, it now says Binatone made in Japan on my finger. That wasn't ideal. So I won't hold the antenna when I press transmit. And it drops off quite rapidly, but initially when we press transmit, that's doing about 3.6 watts. you've got quite a small heatsink there, and they're hoping. I mean, we've been tuning that up, and it's been constantly transmitting for 3 minutes. So, you know, what do you expect? I'll just go once again. Yeah, it's 3.6, 3.7 watts. So, but it isn't lying. Do you remember the handheld we did with the German name on it? Can't even remember the name now. Oh, Kaiser, and it said on the box it was 4 watts, and then we looked at the output transistor and it was 1.8 watts. Well, in this case, it's a 4-watt radio, but the output transistor is about 9 or 12 watts. You know, so you know it's on top of the job, and it could do it. I've not seen that Mitsubishi driver transistor before, which looks to be a 2SC 1973. So it looks like a 2SC 2086, a kind of oversized TO92 case device, but there you are. So let's see what this does on low power. It's not adjustable. You know, you get what it is, and on low power, it's very, very low. It is 150 milliwatts. I don't get that. Yeah, it's doing full power on full power, as you'd expect, and 150 milliwatts on low power. You'd expect a preset for that, but I know there isn't one. Okay, so let's move on to deviation. I guess I'll try and get our little oscillator underneath it. Wallow. Wallow. Well, it is correct. It's doing 2.2 to 2.5, and the preset for it is just there, RV3. So it's just under that battery cover, RV3. There's no point adjusting it because it is spot on. I'll just show you once again. I'll key it up without touching the antenna. Wallow. So, yeah, there we are. So that covers the transmit. So we've taken that from, what, 800 milliwatts to 3.7 watts. I'll just check once again. Yeah, it's there. So that was really screwed up, and it didn't help with the core being so broken in that one that it wouldn't move, but with the tool. So we've sorted it. Good. Now I'll move on to the receiver. So I'll lose that, and I'll just make sure the signal generator is on channel 27.9. Oh, I'll tell you what we didn't do. We didn't check it was on frequency. So I'll just switch on the other camera. So channel 20, it should be 27.79125. 27. Oh, we're not on channel 20. Now this is the trouble when you haven't got the display working. So this knob is actually out. So I need to take that knob off and put it on in the place where it says 19. I'll have to do this again, aren't I? Because the radio needs cleaning. Or is it 18 that is? Let's see what happens now when I key up. No, it's a channel out again. Now we're shorting out the connector again. And as I've said before, it really doesn't matter. The power supply is set to cut out at 1.5 amps. Doesn't damage the radio, doesn't damage anything. It's just what happens in reality. You know what? I don't think you can put it on in the right place. So that's 80125. So I want 79125. Which is there, but that's in the 18, that's in the 19 position. I think what's happened here is that the insert has come out and someone's glued it back in the wrong position. So that's quite frustrating. I'm going to have to see whether we can get it out with a scalpel and then glue it back in the right place, because you can only relocate this on its spigot every 2. And so it's either, if I move the pointer, it'll now be pointing to 17, or if I move it, it'll be 21. I want 20 for the frequency given. So that's annoying at the moment. But we'll look into that situation with the display sooner rather than later. Now I need to look for a frequency adjustment, if there is one. It's so minutely out, it isn't out, you know what I mean. But I'll tell you what, there is. Now this looks like it's one of these radios that's got multiple crystal mixer. Now there isn't an adjustment for 10.24, so one of these is going to be transmit and the other one's going to be receive. So we're going to be back to using a marker oscillator to set up the receive. Now which one is transmit and which one is receive? Can I see the photocopy of the photocopy well enough? And the answer is no. So with an educated guess, I'm going to go for the hardest one to get to, which is the inner one. And it isn't that. So I'll go to the easy one to get to, the one on the left. And it is that. So the 277913 will do nicely, that's fine. So we'll take that camera back off. So it's definitely receiving. You're listening to 3 microvolts. So we'll put that into the synod meter. Looks like I'm going to have to back the squelch off. So I've set the sound meter to around about 4 decibels, and we're listening now to, actually I can change scales. It's a bit loud, that. Okay, so I'll start at, well, that looks like it's the detector, so we'll come back to that. So to be honest, I think we work at L, I think we start here, to be honest, the other way around to what I originally thought. I'll just put an S9 signal on, and I'll just check with the oscilloscope that I've got the detector, and I'm accusing this coil, whoops, when I get it into camera, appear to be the detectors. I'm right. I actually got a little bit out of it there, so that's pleasing. So I'll just drop the attenuator back down. That's now 0.7 of a microvolt. So we've come a long way from 3 microvolts for the same. So just check this one. Don't know whether this is. It's not making much effect on the signal to noise ratio. Try it at 6 decibels and see whether I can get a tuning point. Yes. So that's 0.3 of a microvolt we can just hear. So I need to set up the IF signal generator. We'll take the tone off. So we're using this old Pi instrument once again. You have to remember that this is 9 volts. Not sure where my BNC leaders run off to. But luckily, I know where there's another one. Pinches it off the bench behind me. So, as ever, we're trying to get a musical note into the IF. So we're loosely coupling it somewhere into the IF. And then I'm going to adjust that. Of course, I've put the meter, I've put the IF oscillator, IF signal generator on top of the. So now we'll adjust that trimmer. Now we've got that musical note there. Oh, that's nice and pronounced. So with that trimming tool, which I've put down somewhere, we'll adjust the inner variable capacitor. So it's very minutely off frequency. Let's see where it is. $27,79113 on receive. So it is neither here nor there. Now ideally the 10.24 would adjust, but it doesn't. So without changing that crystal, we've managed to get the transmitter okay, but the receiver is very minutely off. but it's so minutely off. A lot of new sets are 10 times that amount off and not adjustable. It's well within specification, but I would have liked it to be spot on. So we'll disconnect that, take it away, and we know we're as good as we're going to get. And I'll just see if I can get you some figures for how good the receiver is or how bad the receiver is. It doesn't help having adapter trees, but let's have a look. So for 20 decibel cyanide, it's actually 3 microvolts, and the specification here says better than 1 microvolt for 20 decibels. So either that's lying, or this radio's not as good as it once was, or our adapter tree isn't helping. Let's look at the more meaningful ones though. 12 decibels, it's 1 microvolt, and for 10 decibel cyanide, it's 0.85 microvolts. And we can hear it down to about 0.28 of a microvolt. So I think it's working fine, and of course it's going to work better on a telescopic than it would through all these adapters. So that has covered it, but I've got to find out now why we've got no display. So I'll just disconnect it from the test equipment. We don't need that. We don't need that. We're going to have to keep it powered up. Get rid of that. I'm going to have to go very shortly. No, I'm going to have to dismantle it, and I'll do that later on today. So there we are. It's now 20 to 10. I should have disappeared a few minutes ago, but at least the radio is tuned, and we've brought it up from a 3 microvolt receive to 0.3 microvolts, and we've brought the transmitter up from 800 milliwatts to 3.6, 3.7 watts. So I'm pleased with that. And just remember, it's on a 12 volt supplier, not 13.8.